Hello. I ran into a little bit of bad luck, so unfortunately I will not be able to be with you guys today. Today we are going to be doing lesson 551, day 3, triangle proofs. By the end of, homework tonight is 551 worksheet day 3, assignment number 9. This is on your calendar. So our objectives for today, by the end of class, you should be able to use vertical angles in a proof, use complementary supplementary theorems in a proof, as well as use the angle side postulate to prove two triangles are congruent. So what we're doing today is we're kind of taking the last two lessons, the vertical angles, the complementary supplementary theorems, and incorporating them into our triangle proof. So go ahead, let's get started on our notes. Take a look at example 1. First of all, we have a typo in our notes. Sorry. What I want you to do is I want you to change the given information, this right here. Go ahead, change it to line segment BD bisects angle ADC. All right, so with all proofs, first thing we do, we start with that given. Let's mark our diagram. Let's kind of get a general plan together. So what I know for certain, I'm going to mark in one color. So line segment AD is congruent to line segment CD. I'm going to mark in black because that's flat out given to us. Line segment BD bisects angle ADC is given to us. What's not given to us is that angle ADB is congruent to angle BDC, but we know that that's something that we can infer because we know what bisecting an angle means. So I'm putting that in a different color because it's not something I actually have said. I have not said anywhere that angle ADB and angle BDC are congruent. But that's something, again, that we know based on the given. So I'm marking it in a different color so I know that it needs to be said. Anything else that we can mark based on what we know? How about that reflexive property? So already I got a whole bunch of information here. Nothing written down, but a whole bunch that we will write down. And so now let's take a look at our proof. So we're trying to prove that triangle ABD is congruent to triangle CBD. And if we take a look, we know a couple ways to do that, right? Side angle side, side side side, angle side angle. And if we take a look at what we have, side angle side, that's going to be kind of our approach. So now let's go ahead and let's actually do the proof now that we have an outline. So the first thing that we're going to do is, of course, start with our given. So let's get that written down. And don't forget that you can pause this video at any time. If I'm going too quickly, you can rewind if you need to listen to anything that I say over again or didn't catch what I said the first time. So let's go ahead, let's write down some of our information. So I'm going to start with the given information. I'm going to, from the given, write down what I can conclude. So I know that line segment BD bisects angle ADC, and what that means is that it's going to cut that angle into two congruent angles. So I'm going to go ahead and write this down, that angle ADB is congruent to angle BDC. Reason for that, we can say definition of angle bisector, we can say line segment BD bisects angle ADC, whatever our reasoning is for it, as long as it's a sound reason. So now that we said that, I'm going to go ahead and change that color to black, just so that I know that it's in my proof. So next, let's go ahead, let's get that reflexive property in there. So let's go ahead and say line segment BD is congruent to itself by reflexive property. And again, I'm going to go ahead, change that now, so I know it's in my proof. So again, goal is we're trying to get those two triangles congruent. Triangle ABD congruent to triangle CBD. And if we look now, we finally have enough. Side, angle, side. Side, angle, side. All of it's said. So let's go ahead and finish that proof. triangle ABD is congruent to triangle CBD by side angle 5. So that was kind of like a nice little proof to kind of get us into the back into triangle proofs. So let's go ahead now and let's use a new theorem. So go ahead, take a second, pause the video, read the given information, fill in the diagram. All right, so if you take a look at my diagram, you'll notice that I have two different colors. I have what's given marked in black and then what I can infer from my given marked in red. So already we can kind of see the way that this proof is going to play out. So let's go ahead and get started. Let's write down our given information. That line segment SV is perpendicular to line segment SR. Line segment SV is perpendicular to line segment VW, and that T bisects line segment SV. Oh, so already I notice I have a mistake. I don't know those two segments are congruent. I just know right now that T bisects that line segment. So that should be in my red color as well, because that's not something I've said. So we're going to have a bunch of steps here to kind of get this all down, and the order of which we do it doesn't matter too much. I'm just going to kind of start from the top down. So the fact that line segment SV is perpendicular to line segment SR means that I have a right angle right there at angle S. Same thing here. The fact that line segment SV is perpendicular to line segment WV means that I'm going to have a right angle right there at vertex V. So let's go ahead, let's write that down, make that our second step. That angle S is a right angle and angle V is a right angle because that's the definition of perpendicular. And again, if you wrote down this information here as our reason, that would be fine too. So now that I said that angle S and angle V are right angles, what do we know that that means? Well, all right angles measure 90 degrees, meaning all right angles are congruent. So the fact that angle S and angle V are right angles means that angle S has to be congruent to angle V. So there we go, we already have 3 steps. Angle S congruent to angle V, both right angles. So I'm going to go back to my picture now and change that. Say, hey, look at that, I finally have a set of angles congruent to each other. I'm on my way to proving those two triangles are congruent, but not quite yet. So now I'm going to look at the second thing that our given information told us, that T bisects line segment SV. So the fact that T bisects line segment SV means T is the midpoint, meaning that line segment SV is being chopped into two congruent segments. So I can now conclude that line segment ST is congruent to line segment TV, because that's the definition of a segment bisector. So let's go ahead and write that down as our next step. So line segment ST is congruent to line segment TV, definition of segment bisector. Or if we wrote because T bisects line segment SB, that would work as well. So again, I'm getting there. I have angle, I have side, not enough information. I still need more information. Well, luckily on Friday we learned vertical angles are congruent, or opposite angles. So if we take a look here, we have a set of opposite angles, angle STR and angle WTV. So we know that those two angles are going to be congruent because they're vertical angles. So let's go ahead and make that our next step. Angle SPR is congruent to angle VTW. Because vertical angles are congruent. And finally, I have enough information to prove that these two triangles are congruent. I finally have a set of angles, sides, angles, so I could use that awesome, if we look, angle, side, angle postulate. So finally, we can get to our conclusion that triangle RST is congruent to triangle WVT by angle, side, angle. And just to verify, angle, side, angle. There they are. Good, good, good. Let's go ahead and do one more proof. This one's going to use both complementary theorems as well as vertical angles. So again, at this point, read your given, pause this video, jot down your diagram, and then press play. So if I mark my given information, I have line segment TN is congruent to line segment TR, angle 1 is congruent to angle 2, and then I have a bunch of complementary things. That angle 3 is complementary to angle 1, angle 4 is complementary to angle 2, so that's going to play a part in a second. What we're trying to prove here is that triangle TNO is congruent to triangle TRS. So since there's kind of a couple triangles happening here, I'm just going to go ahead and highlight triangle TNO and triangle TRS, just so that I know which two triangles I'm working with, so that I don't get confused and accidentally say, you know, certain angles are congruent and have that confuse us for our proof. So if we take a look here, the only two pieces I know are congruent from my given of those two triangles is line segment TN is congruent to line segment TR. So we're going to have to take a look at this diagram and figure out, well, what I need more. I need another angle, I need another side, or I need two sets of angles, or two more sets of sides. Well, right away we should be seeing, hey, angle 6 and angle 5 are opposite each other. That means that they're vertical angles, and that means that they're congruent. So that's something I'm going to mark again in my red color because I'm going to infer it, not because it's given to us. And then if we take a look at this information here, I know angle 1 is congruent to angle 2. Well, yesterday we learned, on Thursday we learned, or Wednesday, depending on which day you were here, that angles that are complementary to congruent angles, angle 1, angle 2, have to be congruent themselves. So I'm also going to be able to say that angle 3 is congruent to angle 4 based on that theorem. And now if we look in our triangles, that looks like an angle side angle. So now let's get that all down. So let's first start by writing down our given. Line segment TN is congruent to line segment TR. Angle 1 is congruent to angle 2. Angle 3 is complementary to angle 1. Angle 4 is complementary to angle 2. So now we just kind of pick where we want to start. I'm going to go ahead and get started with, again, the given. So I'm going to say that angle 3 is congruent to angle 4 because angles that are complementary to congruent angles are congruent. Since angle 3 and angle 4 are complementary to angle 1 and angle 2, which we know are the same, angle 3 and angle 4 have to be equal to each other in order to add up to 90 degrees. So now that I said that, I'm going to mark angle 3 congruent to angle 4 in that black color, so I know it's in my proof. So again, I got angle, I got side. We need to get one more set of angles. So now I'm going to say angle 6 is congruent to angle 5 because they're vertical angles. So angle 6 is congruent to angle 5 because we know vertical angles are congruent. And now I'm going to change that because check, I said it. And finally, we have enough information now to say these two triangles are congruent by angle side angle. So step 4, triangle TNO is congruent to triangle TRS by angle side angle. And just to verify, angles in line 2, line 1, and line 3. All right. So third angle theorem is a theorem that we're going to prove later on, but for right now, what our third angle theorem says that if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangle have to be congruent. We can look at this mathematically. We know that these two triangles have to add up to 180 degrees, so there's only one possibility for the measure of angle N and the measure of angle R, which is how we know that they have to be congruent. Very similar to our complementary supplementary theorems. So we're going to go ahead and use this because if we have, let's say, angle, side, it turns out that really that's just angle, side angle, because of this third angle theorem. So that lets us use angle, side as another way to prove two triangles are congruent. So let's go ahead and use angle, side. I'm going to let you guys try this proof on your own first. So again, go ahead, read it, mark your diagram, and I'm going to give you a hint. We're going to use angle, side to prove these two triangles are congruent. So go ahead, pause this video, try it on your own, and then when you're ready, press play. All right, if you have not paused yet, go ahead, pause, because I'm about to show the answer. All right, so if you tried this on your own, you should get a proof very similar to this, 4 steps. You may have switched around step 3 and step 2. But the reason why this one is angle, side and not angle, side, angle is the way that the order that we're given. So we're given that angle B is congruent to angle C, and the fact that line segment BE bisects line segment AD allows us to say what we said in step 2, that line segment AE is congruent to line segment ED. And then our vertical angles theorem said that angle 1 was congruent to angle 2. So the reason why this one's angle, side is the order. Notice the congruent sides are not in between. If this side was congruent to that side, then it would be angle, side, angle. But because it's our not included side, it follows that we go angle, side, angle, side. So very similar to angle, side, angle, and really it's just another way, an easy way in some situations to prove two triangles are congruent. All right, so your homework tonight is again a bunch of triangle proof practice. We're gonna, if you look at your calendar for the week ahead, practice triangle proofs a little bit more. Hopefully by the end of this week, they'll be starting to make more sense before our test next week. If not, don't forget I'm available in Math Resource Center, third period. Otherwise, I have before school free, first period free, and fifth period free if you need any help, because these can be hard. I hope to see you all tomorrow.